Once phase 1 comes along and rollups move to ETH2 sharded chains for their data storage, we go up to a theoretical maximum of 100,000 transactions per second. Hello and welcome to Ethereum Audible, Ethereum in Depth. I'm Yoshua Zlatogorsky, and this is where we read the best in the Ethereum and Web3 ecosystem. Today we are going to be diving into the roadmap for Ethereum 2.0 and reading a Rollup-centric Ethereum roadmap. We're going to be continuing the theme we started last episode with the Beacon Chain primer, and that is to dive into what Ethereum 2.0 really is, what it's built of, and what the roadmap is for the future. And this connects a lot with the first two episodes of this podcast, Why Proof of Stake and Ultra Scalable Ethereum, because those two outlined and really laid out the premise for why the shift to a proof of stake chain and how can Ethereum scale. And in this episode, and also in the next few read-throughs, we're going to be diving a little bit more into the nitty-gritty details of what that means. And today we are starting out with a post by Vitalik on October of 2020 in the Fellowship of Ethereum Magicians Forum, the FEMs, called "What Would a Rollup-Centric Ethereum Roadmap Look Like?" But first, I want to thank the sponsors of this show who made this episode possible. This episode is brought to you by Alpe Audio. Want to learn on the go but need more depth than a podcast? Alpe is the app for you. It's an audio education app that brings great in-depth courses that are as fun as podcasts but as educational as a degree. Each lesson comes with summaries, additional resources, flashcards, and more. You can even find Ethereum Audible on Alpe with all of those additional resources. If you want to check it out, head over to get.alpeaudio.com, and that's A-L-P-E, Alpe, A-L-P-E. Let's go. What would a Rollup-centric Ethereum roadmap look like? Last week, the Optimism team announced the launch of the first stage of their testnet and the roadmap to mainnet. They are not the only ones. Fuel is moving towards a testnet and Arbitrum has one. In the land of ZK Rollups, Loopring ZK Sync and the Starkware tech-based Diversify are already live and have users on mainnet. With OMG Network's mainnet beta, Plasma is moving forward too. Meanwhile, gas prices on ETH1 are climbing to new highs, to the point where some non-financial dApps are being forced to shut down, and others are running on testnets. The ETH2 roadmap offers scalability, and the earlier phases of ETH2 are approaching quickly. But base layer scalability for applications is only coming as the last major phase of ETH2, which is still years away. In a further twist of irony, ETH2's usability as a data availability layer for rollups comes in phase 1, long before ETH2 becomes usable for traditional layer 1 applications. These facts taken together lead to a particular conclusion. The Ethereum ecosystem is likely to be all in on rollups, plus some Plasma channels, as a scaling strategy for the near and midterm future. If we start from this premise, we can see that it leads to some particular conclusions about what the priorities of Ethereum core development and ecosystem developers should be. Conclusions that are in some cases different from the current path. But what are some of these conclusions? The short term, advancing ETH1 for rollups. In the short term, one major outcome of this is that the Ethereum base layer scaling would primarily be focused on scaling how much data blocks can hold, and not efficiency of on-chain commutation or in-out operations. The only determinant of the scalability of a rollup is how much data the chain can hold, and any increase beyond the current 60 kilobytes per second will help increase rollups' scalability further. There are some things that would continue to matter at the base layer. EIP 2929 to ensure that the chain is safe against DOS attacks at current gas levels, and EIP 1559, both for the ETH burn and for the benefit of making it easy to send transactions that almost certainly get into the next blocks. which rollups still depend on for confirmations. A new elliptic curve precompiles to fully support what people want to do with ZK rollups, and the hex, as in a binary tree change, and other changes to advance support for stateless clients. Account abstractions is somewhat less important, because it can be implemented on L2s regardless of whether or not L1 supports it. Other clever base layer features also become relatively less important. ETH1 clients could be repurposed as optimistic rollup clients. Optimistic rollups still need to have full nodes, and if the rollup's internal state transition rules are essentially Ethereum-like with a few modifications, as is the goal of optimism, then existing code could be repurposed to run these full nodes. The work of separating out the consensus engine from the state transition engine is already being done in the context of the ETH1 plus ETH2 merge, which can also help with this goal. Note in particular that this implies that the projects like TurboGeth are still very important, except it would be high throughput rollup clients rather than base layer 1 ETH1 clients that would benefit the most from them. The short term. Adapting infrastructure for rollups. Currently, users have accounts on L1, ENS names on L1, applications live entirely on L1, and so forth. All of this is going to have to change. We need to adapt to a world where users have their primary accounts, balances, assets entirely inside an L2. There are a few things that flow from this. 1. ENS needs to support names being registered and transferred on L2. 2. Layer 2 protocols should be built into the wallet, not web page like dApps. Currently, L2 integrations into dApps requires the user to fully trust the dApp, which is a great decrease in security from the status quo. We ideally want to make L2s part of the wallet itself, like MetaMask, so that we can keep the trust model. This support should be standardized, so that an application that supports ZK Sync payments would immediately support ZK Sync inside MetaMask and ZK Sync inside Status. 3. We need more work on cross L2 transfers, making the experience of moving assets between different L2s as close to instant and seamless as possible. 4. More explicitly standardize on EUL or something similar as an intermediate compiling language. Ethereum's base layer EVM and the OVM used in the Optimism rollup are slightly different compiling targets, but both can be compiled to from Solidity. To allow an ecosystem with different compiling targets, but at the same time avoid a Solidity monoculture and admit multiple languages, it may make sense to more explicitly standardize on something like EUL as an intermediate language that all HLLs would compile to, and which can be compiled into EVM or OVM. We could also consider a more explicitly formal verification-friendly intermediate language that deals with concepts like variables and ensures basic invariance, making formal verification easier for any HLL that compiles to it. Economic sustainability benefits of rollup-centricism. It's an inescapable fact that a crypto project must be financially sustainable, and in 2020 this means millions or even tens of millions of dollars of funding. Some of this can be covered by common public goods funding entities such as Gitcoin grants or the Ethereum Foundation, but the scale of these mechanisms is just not sufficient to cover this level of funding. However, Layer 2 projects launching their own token is sufficient, provided of course that the token is backed by genuine economic value, as in prediction of future fees captured by that L2. An important secondary benefit of a rollup-centric roadmap is that it leaves open space for L2 protocols, and these L2 protocols have the ability to collect fees that can fund development, either directly or indirectly, by backing a token that funds the development. The Ethereum base layer has an important need to be credibly neutral, making in-protocol public goods funding difficult. But L2s have their own public goods funding mechanisms, and that is much less contentious. Leaving open this space can thus be a good strategic move for the long-term economic sustainability of Ethereum as a whole. In addition to the funding issues, the most creative researchers and developers often want to be in a position of great influence on their own little island, and not in a position of little influence arguing with everyone else on the future of the Ethereum protocol as a whole. Furthermore, there are many already existing projects trying to create platforms of various kinds. A rollup-centric roadmap offers a clear opportunity for all of these projects to become part of the Ethereum ecosystem, while still maintaining a high degree of local economic and technical autonomy. The long term. In addition to these short-term concerns, a rollup-centric roadmap could also imply a re-envisioning of ETH2's long-term future as a single high-security execution shard that everyone processes, plus a scalable data availability layer. To see why this is the case, consider the following. Today, Ethereum has 15 transactions per second. If everyone moves to rollups, we will soon have 3,000 transactions per second. Once Phase 1 comes along and rollups move to ETH2 sharded chains for their data storage, we go up to a theoretical maximum of 100,000 transactions per second. Eventually, Phase 2 will come along, bringing ETH2 sharded chains with native computations, which will give us, well, 1,000 to 5,000 transactions per second. It seems very plausible to me that when Phase 2 finally comes, essentially no one will care about it. Everyone will have already adapted to a rollup-centric world, whether we like it or not. And by that point, it will be easier to continue down that path rather than to bring back everyone to the base chain for no clear benefit and a 20 to 100 times reduction in scalability. This implies a phase 1.5 and done approach to ETH2, where the base layer retrenches it and focuses on doing a few things well, namely consensus and data availability. This may actually be a better position for ETH2 to be in, because sharding data availability is much safer than sharding EVM computation. While dishonest majority proof verification of sharded EVM computation requires fraud proofs, which require a strict and potentially risky 2-epoch synchrony assumption, data availability sampling, if done with ZK proofs or polynomial commitments, is safe under asynchrony. This will help Ethereum distinguish itself as having a stronger security model than other sharded L2 chains, which are all going in the direction of having sharded execution of some form. ETH2 would be the base layer that's just powerful enough to have functionality, escape velocity, and no more powerful. What could ETH2 focus on in the long run? Well, 1. Staggering block times on different shards, so that at any time there will always be some shard scheduled to propose a block within a few hundred milliseconds. This allows rollups that operate across multiple shards to have ultra-low latency, without the risks of the chain itself having ultra-low latency. 2. Improving and solidifying its consensus algorithm. 3. Adjusting the EVM to be more friendly to fraud-proof verifications. 4. ZK snarking everything. Compromise proposals. If you are not convinced to go all the way on the phase 1.5 and done direction, there is a natural compromise path to take. Having a small number of execution shards, for example 4 to 8, and many more data shards. The goal would be that the number of execution shards would still be low enough that in exceptional situations, regular computers would be able to fully validate all of them. But there would still be considerably more base layer space than there is today. Base layer space cannot be minimized too much, as users and applications still need it to move between rollups, submit fraud proofs, or submit ZK proofs in ZK rollups, or publish root ERC20 token contracts. And it would still be a large UX loss if those things cost $140 per transaction. Hence, if necessary, having 4 to 8 execution shards instead of 1 could prove significant relief. And it would still be possible for one computer to verify all shards. Today, verifying ETH1 blocks on average takes 200 to 500 milliseconds every 13 seconds, so verifying 8 threads of such execution for short periods of time is completely feasible. One can imagine clients having policies like, if network latency appears low or committees are more than 80% full, rely on fraud proofs and committees under exceptional conditions verify all shards directly. Okay, that was a mouthful of tongue twisters, and I wanted to read this post, even though it's a forum post, not an official kind of article or blog, because this post on the Ethereum's Magicians Forum is really the pivotal moment where part of the roadmap for Ethereum 2 shifts. And the proposal is a critical one because it lays out the mindset shift from going all in on shards and sharding, which we spoke about a lot in the Beacon Chain primer, to a rollup-centric Ethereum roadmap. And the benefits to that, the short-term benefits, the long-term benefits, and you can already feel the seeds of what a future roadmap for Ethereum will look like from this, the ultra-scalable, non-monolithic, modular blockchain that is today's roadmap for Ethereum. So let's break this down, and I want to go through why the shift from shards to rollups, and keep in mind that this post is from October of 2020, so that's a year and a bit ago. B, I want to go a little bit into what rollups actually are and the different kinds of rollups or sidechains that you might have heard about, and their main benefits. And then this will set the stage for the next read-throughs where we're going to be diving into the different kinds of state channels and rollups that are out there. So let's start with A and what's changed, why the shift from 64 shards to rollups. And if you were listening to the last primer on the Beacon Chain read-through, well, shards are just highly complex, and they are the last part in the ETH2 roadmap. This year we have the merge. Last year we had EIP 1559, and sharding won't come until early 2023, probably late 2023. So that's a year and more away. And until then, the space on the Ethereum blockchain is just a commodity that has too little supply and too much demand. There are too many dApps that want access to that valuable commodity of space on the Ethereum blockchain. That's what makes transactions sky high. That's why today, as I record this, it's been $140 to $180 of gas per transaction, which is just insane. But it speaks to the desire that different users have for space on the Ethereum blockchain. And so we can't wait for shards in 2 years down the line to increase the block space. We actually need a solution today. And there are different kinds of layer 2s and channels. Some are side channels like the Lightning Network on Bitcoin. Plasma is a solution. And then rollups are the third kind. And that's what our next read-through is going to be. It's going to be breaking down each of those. But the short answer is that you can't wait for shards. You need rollups today. Now, what are rollups? Rollups, in essence, take a lot of transactions, they bundle them up, they roll them up, and then they post the final data state back to the chain. And in that final transaction, you can get the proof that all of the other transactions were valid when they were done off-chain. And that bundled transaction basically posts all of that data on-chain. And there are two main benefits to this. One is that it increases the speed of transactions because you're computing off of the main Ethereum network. And so you can have higher transactions per second. You can have more efficient / centralized computation, which makes for a quicker throughput. And the second is that you can lower the cost. And you're lowering the cost mainly because you're bundling thousands of transactions and you're only paying one mainnet gas fee. All of those transactions that happened off-chain, there's only one transaction on-chain. And so that $180 of gas is getting spread out across thousands of transactions. And that's what lowers the gas cost. Now, naturally, there is a trade-off. And that trade-off is security or decentralization. And security can mean just a plain old private keys got hacked and something gets compromised for the rollup. And decentralization means that, well, you're not decentralized anymore. Those transactions are going on some usually permissioned or highly centralized rollup. And during the time that your transactions and assets are on that rollup sidechain, you don't get the benefits of the main Ethereum decentralized chain. And so that's the trade-off. It's increased speed, lower costs, but less decentralization, less security. Now, for many applications, and most of the time, the layers of and the levels of decentralization are not as needed. And that's the main value that rollups can bring. You can basically make that trade-off on an as-needed basis. If you're trading around with low value tokens or playing a game and you just want to play a Web3 game, well, you don't need the full decentralization of the Ethereum blockchain. And you can do that on a rollup, and that's actually part of the main use cases for rollups today. It's gaming. But once you've accrued a lot of tokens or a lot of value or some rare NFTs and you want to secure them for the long term, well, that's when you merge back on chain and you gain the benefits of bringing that asset from the rollup back to Ethereum. And so it gives that control to the user. Today, there are two main kinds of rollups. One is optimistic rollups and the other are zero knowledge rollups. Optimistic rollups are based on the assumption that most transactions are valid and not trying to be false and cheating the system, and therefore the default is to process them. However, there is a watcher. There is someone who does keep an eye out that things are kind of happening in the proper way, and when they see someone commit a fraud, they can submit something called a fraud proof, where they show that this and this node committed so-and-so an infraction, and in return for being the sheriff of the rollup, they can earn rewards. And so there is this inherent kind of checks and balances into the system, with the main problem today being that those watchers, those sheriffs, are highly centralized, and there aren't many decentralized nodes who are playing the sheriff role. So you're really trusting the current setup of whoever's running that layer 2. In the future, that can change, and the fraud proofs can be managed in a more decentralized fashion, but today that's still the case. But optimistic rollups are what make up a majority of the layer 2 rollup solutions today, whether it's Arbitrum, Optimism, you'll hear those names a lot. The other kind is zero knowledge proofs, and the first one of those, Starkware, is just getting off the ground over these past 2 months. Zero knowledge proofs are based on showing computationally, cryptographically, that I've done something without showing you the data. And so you can show the transaction, you can show the proof of having it done properly, but without actually having to show you the proof and the transaction. And that's a much more kind of compelling way for a lot of people in the Ethereum community to do rollups, because they do away with this concept of the watchdog, the fraud proofs. One of the problems with those fraud proofs, by the way, is that when you move your assets from the rollup to the main Ethereum net, well, there's a period of time that those assets are frozen because you need to give time for people to submit fraud proofs for the assets that you just shifted over. So there's usually a 7-day period at the moment of time that you can't do anything with those assets that you moved over. And in zero knowledge proof rollups, that won't be the case. So just to summarize a little bit of what we've been talking about here, the Ethereum roadmap has shifted from a sharding-centric roadmap of 64 shards that do also computation and also data availability to a rollup-centric roadmap, where we'll have one main beacon chain, maybe a few other shards, 4, 8, whatever it is, and those shards will mainly be doing data availability, whereas the computation will all be done on rollups. And so the priorities of the core Ethereum development team have shifted from developing sharding and the feature set that will promote that to making the Ethereum ecosystem more focused on rollups, lowering the gas fees, making it easier to bridge assets, and all of the different aspects of that. The reason to do that is because rollups solve a lot of problems around scale, and they reduce transaction costs. They can increase speed, lower transaction costs, and all of this with sacrificing security and decentralization, but not to a crazy extent. It's up to the users to decide when they want to pay the mainnet gas fees and when they don't. Rollups are just one kind of layer 2 solutions. There are channels, there is Plasma, there are rollups, and there are sidechains, and all of those can play a part in layer 2 for Ethereum. And understanding that is what we're going to be talking about next time.